one local API, multiple model runners, and a scheduler deciding what your machine can actually hold. Ollama looks like a simple command line tool, but underneath it is an orchestration layer for model storage, memory placement, inference processes, and streamed responses. Ollama isn't the model engine, it orchestrates the model engine. The CLI and API are the front door. The Go server owns orchestration, and specialized runner processes perform the expensive model work. For normal model operations, the CLI behaves as a client of the Ollama server. By default, that server exposes its API at localhost on port 11434. Gen maps requests to handlers for generation, chat, embeddings, model creation, downloads, inspection, and the rest of the API, not just two inference endpoints. Pooled models are not stored as one casually named file. A model name resolves to a JSON manifest containing a configuration layer and one or more content-addressed layers. Those layers are stored by digest using the same broad manifest and blob vocabulary familiar from container registries, while the exact model directory depends on your operating system. This is where the old native first fallback story breaks down. In the current source, Ollama explicitly says that all GGML-backed models are served through the upstream llama-server subprocess. Other workload types, including MLX and image generation, can take specialized paths, while the scheduler interacts with these workers through server contracts for loading, inference, memory reporting, and shutdown. Follow one chat request. The API handler passes it and checks whether the selected model supports the requested capability. The scheduler then reuses an existing runner, loads a new one, or queues the request until memory becomes available. The runner performs inference, and the server streams the result back to the client. The scheduler is the control center. It maintains a bounded queue, tracks loaded runners, refreshes hardware information, and estimates whether another model can fit. If memory is insufficient, it can wait for active work to finish and unload an idle model, while current code can also retry certain out-of-memory loads with reduced automatically selected settings. Ollama does not flatten every accelerator into one identical backend. Hardware is discovered, memory requirements are estimated, and an execution placement is selected. A model may be entirely on a GPU, entirely in system memory, or split across CPU and GPU with multiple GPUs. Ollama prefers a single device when the model fits and otherwise can distribute it across the available devices. Once loaded, a runner can be reused by later requests. Active references prevent it from being unloaded while work is in progress. When the runner becomes idle, its keep alive timer begins. The default is 5 minutes, but each request can shorten it, extend it, disable it, or expire it immediately, and supported generation endpoints stream newline. Delimited JSON by default. A Modelfile adds a compact customization layer from parameter, template, system, adapter, license, and message. The instructions are case-insensitive and order independent, but Ollama's deeper value is orchestration, turning manifests, runner processes, hardware placement, queues, lifetimes, and streaming into one approachable API. Is the inference engine really the product, or is hiding all that machinery the clever part? Subscribe for more architecture breakdowns like this.